So to begin with, I think we need to look at the question, what is a blockchain and what does a blockchain offer that a traditional database doesn't? And Bridget already read out a section in my book about what blockchain offers. And I think maybe looking at what a database does is therefore a good start. A database allows us to organize data in a structured manner so that we can retrieve it and search for it efficiently, and we can alter it. Those alterations are then recorded. And in that respect, a blockchain is almost identical. It is a kind of a database. You can't change previous records. It has this immutability. You can only append to it. But other than that, it allows us to store data and then seek out that data later and do stuff with it. And so if you talk to a developer who hasn't looked at blockchain in detail and they're looking at it from a development perspective, you often hear people say, well, why wouldn't you just use a database? And the answer to that is that blockchain isn't solving the problem of searching for and storing data. It's solving a bigger problem than that. It's solving the problem of decentralized ownership in a digital space. And so really, in order to understand blockchain, you need to understand ownership. And ownership is something that we have a kind of instinctive understanding of. If you only have to go to a playgroup for 3 or 4 year olds and you'll see that they get it. They have a very clear concept that this toy is mine and you're not supposed to play with it. And in the real world, ownership kind of falls into a few categories. You have owning a physical object. So I have it in my possession, it's in my house or in my wallet, and you don't have it and I have control over it. In the digital world, it gets slightly different. You generally, either you own something by keeping it secret. So if I have photographs that I took, I keep them on my personal hard drive and I don't share them with anybody else, then I'm the only one who owns them. As soon as I put them out on the web, people can copy them and distribute them how and as they like. So one of the things that we've done in the digital world is we've involved central authorities. We delegate the responsibility of guarding possessions, in quotes, in the digital world to a gatekeeper. And in fact, here I should mention another form of ownership is where you have a registry or a ledger that says that you own something. So I can't physically carry around the plot of land that my house is on, but the government keeps a registry of who owns what land. And when I sell that land on, my name is taken off the registry and somebody else's is put in its place. And it's these registries that I think are the best analogy to what blockchain does, in that it registers ownership in a kind of registry. Now, traditionally, we've used these central authorities. So you have things like banks or government land registries, things like that, keeping track of who owns what. And therefore you have a gatekeeper, or in the case of, for example, a stock market, you have brokers. And having these central authorities has worked reasonably well for us over history, but it's not always good. And blockchain came in and solved the problem of managing a ledger of who owns what without having to have that gatekeeper. And so now I want to briefly sidetrack into something called proof of work, which is what the most famous blockchain uses in order to ensure that this ledger is maintained properly, that we don't have double spending, where people can spend some Bitcoin on one occasion and then spend the same Bitcoin again at another occasion. And actually, the reason I wanted to bring up proof of work is because when you look at the history of blockchain, you'll see a lot of names that crop up. Adam Back, Nick Szabo, Hal Finney, Satoshi Nakamoto. In that list, you'll see that they're all men, except possibly Satoshi Nakamoto. And because it's Bridget's setup here, I thought I would like to highlight the fact that proof of work was actually invented by 2 women, Cynthia Dwork and Moni Nau, in 1993. And given that it's such a key element of how Bitcoin works, it surprises me how infrequently their name actually crops up in kind of historical discussions of Bitcoin. And what Cynthia and Moni did was they came up with a scheme for combating spam email. And you'll see in a moment why that's relevant to open, public, permissionless blockchains and to proof of work. They had this idea that we have a problem with spam email. There's no cost associated with sending out 1,000 or 10,000 or 100,000 emails. Would there be a way of somehow enforcing a cost on sending an email that would therefore mean that spammers can't send these vast quantities of emails and therefore making our lives a little bit less miserable? And they came up with an idea that you should make people who are sending emails do a bit of work, or rather their computer do a bit of work. And the scheme that they had was this idea of conducting this, what's called hashing. It's making your computer cycle through a random number generator again and again and again until it comes up with a random number that is really small. And then you attach that number to the email and it proves that you've done some work. Maybe the cost in terms of time is 1/10 of a second. That doesn't affect the sender of a normal email. But if somebody's trying to send 100,000 or 1,000,000 emails, that time adds up and it becomes infeasible for them to send out that vast quantity of email. And Satoshi Nakamoto took that idea and applied it to the Bitcoin system. It's the sort of underlying principle that maintains the ledger. In order to add transactions to the ledger, you have to do a bunch of work in order to prove that you're allowed to do so. And it builds up this chain in the ledger of more and more work. And it means that people can't go back and rewrite history because they would have to redo the same amount of work. So that's Cynthia Dwork and Moni Nau, and that's their contribution to the blockchain world. So that's one of the issues that has to be overcome in blockchain. Another one I wanted to briefly talk about is something called Sybil attacks. And they're named after a patient whose name was kept anonymous, and the patient had multiple personality disorder. So the psychologist who was looking into the condition used the pseudonym Sybil. We now use that in the computing world in order to talk about cases where people set up multiple accounts in order to subvert a system. And if you have an open permissionless system like a blockchain, where anybody can set up an account to use it, some people are going to set up hundreds or thousands of accounts and use them to have a greater influence over, for example, voting that might take place on the system than they should be allowed to have. And again, proof of work can be used to overcome those kind of problems. So those are sort of two of the technical issues that were resolved in order to make blockchain work. And one of the great things that an open, permissionless public blockchain does is, by being decentralized and not having a gatekeeper, you get something called censorship resistance. There isn't a central authority that can decide arbitrarily to block any particular transaction. And this is important because if you take, for example, banks that handle financial transactions, they have the right to block your transactions. And sometimes this is good. For example, when they freeze the assets of criminals. But sometimes this can be bad. We had cases in the US where banks or credit card companies were basically telling their customers, yes, we know it's your money, but we're not going to allow you to buy cryptocurrency with it. And cryptocurrency was perfectly legal. So really, they should not have taken that decision. But it showed that they do have the ability to arbitrarily censor transactions. And of course, this is a subjective problem in that, to use an aphorism, you may have heard the expression that one regime's freedom fighters are another regime's terrorists. The gatekeepers may decide that they think the activities that are being undertaken are bad activities and should be stopped. And you may personally think they're good. The difference here, of course, is that the central authority ultimately has the complete power over the system, and all you can do at best is appeal. So The other downside of having gatekeepers is that they can charge you for the service. And when we use credit cards, we're paying a fee in order to maintain and run and set up the financial system that it relies on. So it's not, again, clear cut, because of course, if you're using a blockchain system, you are also paying a fee, but at least you're paying the fee in the form of transaction fees to the entire system and not to one central company that's profiting from it. So it becomes a bit more democratized. There is nothing stopping you from running a mining node for a blockchain system in order to take some of the fees that are being paid. Whereas I can't decide that I would like to share in the profits of a private bank, for example. If it's a public bank, then I could buy shares in it, but that depends on the particular corporation that's running the system. So I've talked a bit about the kind of blockchain background. If you're really interested in understanding the nuts and bolts, I'll use this opportunity to plug my book one more time. I cover a whole bunch of these things in that book, and it is an entertaining and educational read. So I suggest you go and look there, or there are plenty of articles online as well to go and look up.